It seemed like an easy DOM, but the big thing I wanted you to get into your system was how we denote the entries to a sequence. This is the term we're on. This is the next term. This is 2 terms from now. This is the previous term. That A sub n notation is what you need to get comfortable with because you're going to be seeing that on test stuff. So, questions over that? This DOM is an example of what we're doing today. This is called an arithmetic sequence. Who thinks they can tell me why it's called that? Somebody can tell me why I think it's called an arithmetic sequence. Sure. What is that pattern? They all have patterns. What would you say? It's not a product. That's not really the word I'm looking for. I see what you're saying. Look at the actual numbers. What is happening in the sequence? You add 4. You add 4. An arithmetic sequence, you just add something every time. It's a very straightforward sequence. So, here are the 2 formulas you're going to need today. I'm going to underline them in bananas. You don't really have to write down everything. Just kind of write down the title. You want to write down the title of it. One is a sum formula. The other is a general term formula. And you want to write those down. This is 10-2, yes. 10-2. The general term and one is a sum formula. All this day. That is. Yeah. Oh, she was called for drug test. Yeah, I know. But did Jalen?
Yeah, she was up there now.
It reminds me, all of your work for this mini quarter, whether it was for Mr. Cox or myself, is due on Monday. Hopefully I should have it by Friday, if not tomorrow, probably Friday, a printout of all the assignments in this class, what I have, what I don't have, and then that'll be due Monday, if you're missing anything. Some of you, I noticed, are missing several of Mr. Cox's assignments. Hopefully you already know that. But everything should be back there on that board.
Why did you say goodbye? Why did you say goodbye?
He didn't say goodbye on his last day? Well, that's right. I'll tell you. He was going to teach this class or give that test that day, but then he actually got a job. Did he tell you all he got a job? He's primary. He is at Big Sandy High School now. He's actually teaching. He's a full-time teacher. So they bumped him up to the majors early. But before he could go, he had to finish all the stuff from here, and he wasn't prepared to leave that early. So he had to take the beginning of that day to get everything done so that he could hurry on over there Friday afternoon and get all the stuff he needs to start teaching there yesterday. So today is his 3rd day in his new job. So hopefully he's doing well. That's why he didn't say goodbye. Time was not permitting. Yeah, I heard he had you all count that one day. Yeah. You know, everybody has little ticks in their personality. I applaud him for trying to conquer that one. Okay, now I'll let you know when you need these formulas. So you need to now write the formula? I'll let you know what slides you need these formulas on. Of course, the hint will be in the directions. If you see the general term in the directions, you probably need the general term formula. And if you see the sum in the directions, you probably need the sum formula. If you don't see either of those terms, you probably don't need those formulas. Now, A sub n is the current term. Here's how this one will be used. It'll be like, what's the 17th term? So you're going to be looking for like A sub 17. That's what you're going to be looking for. A sub 1 stands for the first term of the sequence. Well, let me ask you this. If you're looking for the 17th term, then n is 17. It's not really a question. And d is what you're adding every time. So, like, for instance, what would d be for our DOM? Exactly. Exactly. Click. Write the first 6 terms of each arithmetic sequence. They tell you where to start, and they tell you what to add every time, and it's literally that simple. Let's try number 5. So that's 300 minus 90 minus 90 minus 90 minus 90. First 6 terms. Every arithmetic sequence is really a recursion formula. Remember how yesterday we had those complicated ones with the n minus 1s and everything? Every sequence from here on out is a recursion formula. You're just adding or subtracting something from the previous term. So when you get down to 9 through 13, don't freak out. It's the exact same thing. They just made it look more complicated. Our first term, let's do number 13. Our first term is 1.6. Then we just plug that into the formula. So 1.6 minus 0.4. 1.2 minus 0.4. 0.8 minus 0.4, etc., etc. So 9 through 13, you don't have to do some special anything. This just means plug in the previous term. That's why we did the DOM, to get you to recognize that. Try number 11 on your own, and I'll call someone at random for the answer. Numerel once. Once, or is it once? Uno. How about that? Number 11. No, I'm trying to say 11. Is it once? Thank you. No. D is what you're adding. A1 is your first term. The D, see, instead of a D, they gave you a formula that you plugged it into. So really, like Latif on this one, the one we just did, really this is our D. Because we really just subtracted 0.4 every time. By giving you a formula, essentially whatever they add to the recursion one is your D. So on number 11, your D would be what? There you go. Okay, eeny, meeny, miny, Sarah Ferguson. What is the answer to number 11? Very good. Why does it seem like you had an echo? Or were you the echo? Never mind. Yeah, that's what I heard. It was really throwing me off. Okay, questions about this slide? That was dramatic. Questions? Click. All right. Now, I thought they'd say the actual general term. Come in. Oh, I'm not the coach anymore. Go to conditioning, and you'll know. Okay. This is the one we're using the general term for. So let's jump into number 17. We are looking on number 17 for A sub 50. That's the general term formula. The formula. Somebody read that formula nice and loud for me again. Very good. Thank you. A1 is what? In our problem? 7. What is our n value? 50. That's right. That is your n value. So 50 minus 1. And what's our d value?
5. So 7 plus 49 times 5. Do not forget your order of operations. Parentheses, then multiplication, then addition. Ma'am? This is the general term of an arithmetic sequence. Here's how you know when you use it. If it asks you for a sub something, that's when you need it. If it asks you for a sub something, that's when you need it. So, who punched this in? Thank you. The correct answer to that would have been Marco, but thank you. Or I did. But I will accept 252 as well. Raise your hand if you have a question about where we got a number in that formula. Yes, ma'am. That's exactly what you do. Try number 19 on your own. Nope, check that. 21. Try 21 on your own. One. Mr. Bunge, how'd you set it up? Very good. And Lazarus, what you get? 91. Yes. 142, negative what? What was it? Okay, good. Questions? All right. Skipping on ahead. Write a formula for the general term and then find the 20th term. Okay, here we go. First thing we need to do is just write a formula for the general term. So let's do 25 together. So we're looking for a sub n on number 25. What is our a sub 1? 7. What is, well, we don't know n yet. What's our d value? Negative 4. Very good. There you have the formula. Now all you have to do is find the 20th term of that formula. So right, a sub 20. It's the pattern. It's what it's going up or down by every time. In an arithmetic sequence, you can just take any term and subtract the previous term and get your d value. Miss French, what'd you get? Alrighty, I'll wait. What's for lunch today? Oh, thank you. Sorry. Questions? All right. All we did was plug in 20 for n. We plugged 20. Yeah, all right. That's really big. Negative 532. What did you multiply 19 by? Okay. Check. Again, we plugged 20 in for n, so 20 minus 1. It's all right. You weren't here. All right. 31 and 33 look complicated, but Latif, I'm going to come back to you for this one because you asked me. Remember when you asked about these, what's our d value on number 33? Very good. That is your d value. So everything's still the same. So for 33, a sub n, what's our a sub 1, Katie? There it is. Plus n minus 1, and our d value is just whatever's being added or subtracted to our term. There you go. Now plug in 20 for n. and you're golden. So those recursion ones aren't any harder, they just look funky. Jenny, did you get a sub 20?
Not negative.
Will somebody verify that? Awesome. Negative 100.
What did you go with? Oh,
Like on number 31.
Yep.
The formula with the n plus 3 with
It's always n minus 1. It's always the plus 3 is the d value. Yeah, alright. Are we good? Okay. Ooh, which formula do you think you're going to need for these? That's right, sum formula. So, we're actually going to start with number 43. We're going to start with the last one. So somebody tell me the sum formula. Holly, what's the sum formula?
f of n equals n over 3 times n1 plus n.
Thank you. So, on 43, we're looking for, well, actually, probably shouldn't start with this one. Because, well, okay, that's cool. I guess what you need to do on these is actually list, well, there's got to be an easier way to do that. What's that? You could just write out the terms and count them. I don't know if that's the quickest way, but I encourage you to use your little, well, not your little noggins, but you know, your, hey, we can figure it out like this. I know how we could do this. I'm kind of biting off more than I can chew here. There's more than one way to find out what n is, because it doesn't tell us how many terms there are. But what you could do is say, well, we know that a sub n, whatever it was, we know our last term is 45. We know our first term is 21. We don't know what n is, but do we know what we're going up by every time? Yeah, we know we're going up by 2 because it says every even number. And because it says even number, that was stupid. It's actually 44 and 22. If our first term was 22, because it says every even number between 21 and 45, and our last term is 44, we can find out how many there are by kind of using our general term backwards. So if we subtracted the 22, that's 22 equals times 2. So that 22 equals 2n minus 2. Add the 2, divide by 2, and what do you get? 12 is right. 12. So now we can use our sum formula. S of the first 12 terms of 12 over 2 is the first term plus the last term. Punch it in and you have the sum of every term in that sequence. Which is what, someone? 396? What doesn't equal 12? We had to add the 2 first. Add the 2, then divide by 2. Sweet. I'm pretty sure on every single one of these, except for maybe 39, you have to find something, either n or d, and you're going to need the general term to do that. So, let's try 37 together, and then I'll cut you loose for one. 37, we're looking for the first 50 terms. So this one we have n. Let's just plug everything into the sum formula until we hit a roadblock. N over 2. What's my first term? What's my last term? That's what we don't know. So you have to go back to the general formula to find that out. So that'll be, we're looking for a sub 50 of a sub 1 plus n minus 1 times d. What's d? Just positive 4, right? It's adding 4. Punch that in. Let me know what you get for a sub 50. $186. Punch that in for A sub 50. Now you can find the sum. 25 times 176. Anybody? 39. 4004? 2400? Oh, okay. There we go. On the sums, you're going to have to use the general term to find some variable on most of them. I don't think you do on 39, but I'm pretty sure the others you do. Try 41. Try 41. Actually, try 35 and 40. Better idea. This row, try 41. These two rows, try 35. And we'll put them together in the end. That row, 41. These two rows, 35. It's whatever term the last term is. Which one do you want? So you don't know what it is yet. So you find it. Yeah, A sub n is just your last term. Oh yeah. The little Minnesota. That's a great episode. I love that episode. I don't know what else is going on that episode. What? Yeah, it was. That's the one with the pen. Alright, we're done. I can talk this. Any questions before we start looking at these? Okay, I won't start. Yes. Are you hot? Okay. Well, how about this? I won't turn the air on. I'll turn the temperature down and let it naturally come down to hopefully a nice homeostasis. Is that right? Isn't that what they call where it's like all good? What's homeostasis? Am I being the same? So can't that apply to temperature, or does it have to be health? I'm looking it up. Mr. Webster, what is homeostasis? Why does it have to be the body? I've never heard it. Because it's homeo? Homeo, wherefore art thou homeostasis? That was really bad. Homeopathy. What? Well, homeo is, it says similar. I know homeostasis. Oh, here we go. Nope, nope, I'm wrong. It doesn't say anything. I just thought I found it and I didn't. Yes, we do. We most certainly do. Yeah. What'd you say? Serious jerk. Wikipedia. Here we go. Dictionary. .com. The ability or tendency of an organism or cell to maintain internal equilibrium, dang it, by adjusting its physiological processes. So I guess if we viewed this whole class as one big organism, what didn't I just do that? Here? Like right here? Okay. Google died. Okay. Definition? / definition? No, it's not. That's a URL bar. I'm telling you, it's no.
No, it's not. See?
And I be telling you, this is not a Google search bar. I just did that. What? This is a much bigger waste of time than I thought it was. Hey, I said say it. The tendency toward a relatively stable equilibrium. Aha! This one does not even mention a person. But, so I was actually pretty accurate with my thing. The tendency toward a relatively stable equilibrium among interdependent elements, which are all of you. Nailed it! We were looking for a nice homeostasis. I'm not even a science person. I'm proud of myself. Okay. All right. Sorry if I busted your eardrum. All right. Someone, eeny, meeny, miny, Amanda. What do you get for 35? 1220. We have some second and thirds. Does somebody want to challenge 1220? Okay. Well, that's because we were talking about homeostasis. Let's see. So, if we start filling out the sum formula for number 35, S sub 20 equals 20 over 2 times 4 plus problem. We don't know what A sub 20 is. So we have to find A sub 20, which is A sub 1, plus N minus 1, which is 19, times D. What's my D value, Sarah? That clap was so good it hurt my hand. What? Just take any term, subtract N minus 1. So back to my question, what's D? D. Take any term, subtract the previous term. 6. All right. So 6 times 19 is 114 plus 4 is 118. 10 times 122 is 1,220. That is correct. Brianna, what'd you get for 41? All right, Mr. Powers, what'd you get? 930? 930. Did someone second/challenge that? Blake? Let's take a look. So, sum of the first 30 even integers. Now, logic dictates that that would probably mean there are 30 terms. Well, let's not jump to conclusions. Let's find out what n is. If the last term is, I don't even know that, do I? Well, okay. What's our d value? 2. What's my first term? 2. All we really need to know is n, although we don't know the 60th even one either. Let's see. Now, what's a fast and simple way to jump to the 60th even number? Wouldn't it be 121? What? 122? Find the sum of the first 60 positive even integers. So it'd be 2, 4, 6, 8, 10, 12. Would that include 0?
0 even positive or negative.
Oh, I'm an idiot. Doesn't matter anyway. We know what n is. 60 minus 1, so 59. So we're looking for a sub 60. So regardless, we could have just done that. So that's 120. Yeah, good call, Ryan. All right, back to our formula. S sub 60 equals 60 over 2 times a sub 1 plus a sub n. 60, what? What is that? What's 30 times 122? Is that what this is? Yay! 3,660. Questions? Click. All right. Write out the first 3 terms and the last term. These are all arithmetic sequences. They just want you to observe that they're arithmetic sequences. So, we're going to plug in the first few terms. 47. You plug in 1, what do you get? 2. You plug in 2, what do you get? You plug in 3, what do you get? Negative 4. Plug in 30, what do you get? Negative 85 is correct. All right. Very good. Now, the whole point of these is actually say find the sum. Yeah, then use the formula to find the sum. You can do the sum sequence I showed you yesterday. You can do the sum formula I taught you today. Because now that you have the pattern, you have a sub 1, you have a sub n. What is our d value? Negative 3. What's interesting about these is, for an arithmetic sequence, it's actually the number that's being multiplied that is your d value. What's your d value going to be here? 4. 4, 8, 12, 16, etc. What's your d value going to be here? 5. Yeah, the 3 just kind of gives you a starting point. So, all you have to do, write out the first 3 terms, the last term, and then use your sum formula to find the sum of that sequence. So for this one, the sum of the first 30 terms would be 30 over 2 times the first term plus the last term, which you could plug in. What did you say it was, Nate? Very good. I think that's right. Actually, it can't be right. It'd be 15 times something. It has to end in a 5 or a 0. Oh, no, come on, dude. Did I, though? 15 times negative 83, someone. You actually were almost exactly halfway. Almost. Not exactly. Actually, I'm wrong. You were like almost it off. All right, anyway. Are there questions about where any aspect of that problem came from, why we did something? It asks you for the first 3, the last, and the sum. And I believe that's the last slide. So, before I show you your assignment, since you're going to have to use the general term on all the sum ones as well, you can Incorrect. You can take out. You do not have to do 20. I know this is tempting. 24 and 26. No, Jordan said 4. I said 2. You do not have to do 24 and 26. So if you watch this video, you might want to fast forward through the homeostasis portion. Okay.